Here is a question adding on to the Theory of Equations playlist. I came across this question on a very, very old examination paper, and here it is. You're given an equation, x cubed plus bx squared plus qx plus r is 0, and we're told that one root is equal to the sum of the other two. So we need to show that p cubed plus 8r is 4pq. And then solve the equation 400x cubed minus 320x squared minus 41x plus 42 is 0. So let's start with part A. Let the roots be alpha, beta, and gamma, so that gamma is equal to alpha plus beta. That's what we're given. Right? So now what we will have is alpha plus beta, that's two of them, plus the third root, which is also alpha plus beta, has to equal minus p, which means that alpha plus beta is equal to minus p over 2. We'll call that equation number 1. And secondly, if we use this property of the equations, alpha beta plus beta gamma plus gamma alpha, that's the sum of the roots taken in pairs, equals minus r. That will imply that when we simplify that, gamma alpha plus beta plus alpha beta, gamma is alpha plus beta, so that will be alpha plus beta all squared plus alpha beta, and that's got to come to q. Right, now we call that equation number 2. And the third equation will use the product of the roots. So alpha beta times alpha plus beta equals minus r. And that's equation number 3. So from number 1, we can rewrite that as, we've got that, sorry. From number 3, we've got alpha beta equals minus r over alpha plus beta, which equals minus r over minus p over 2, which is 2r over p. So what we've got then is alpha beta equals 2r over p. We now substitute these into equation number 2, substitute into equation number 2, and what do we get? We'll get p squared over 4 plus 2r over p equals q, which means that p cubed plus 8r plus 4pq, equals 4pq, which is what we set out to prove. Let's look now at part B. Now, we've got to solve that equation up there. I'll rewrite it first as x cubed minus 4x squared upon 5 minus 41x over 100, 400 plus 21 over 200 equals 0. Now, you might be tempted to try and use the factor theorem or the remainder theorem to do this, but I would advise against doing that. Use the hint that you were given in the first part, that one of the roots is the sum of the other two. Okay? So what we'll then do with those assumptions, we'll get that alpha plus beta is equal to 2 upon 5. And alpha beta will equal minus 84 over 320, which equals minus 21 upon 80. Now, beta then is equal to 2 upon 5 minus alpha. And so what we get next is alpha into 2 over 5 minus alpha equals minus 21 over 80, which means that when we simplify all of that, what we will get is 0 equals 80 alpha squared minus 32 alpha minus 21, which factorizes to 4 alpha minus 3 times 20 alpha plus 7 equals 0, giving the following roots. One root is 3/4, another root is minus 7 upon 20, and the third root is the sum of those two, which comes to 2 over 5, and that solves the equation. Thank you for listening.